Picture this, a tiny ice moon, completely frozen over, just suddenly and violently erupting, shooting these massive geysers of subterranean ocean water straight into the freezing vacuum of space. That is Saturn's moon Enceladus. And honestly, those geysers might just hold the key to the absolute biggest question of our existence. Welcome to this explainer, where we're going hunting for the cosmic recipe for life. To get at that ultimate question, are we alone? We really have to recognize that the chemical ingredients for life aren't just an Earth thing. They're actually hiding in plain sight. They're frozen onto ancient asteroids, and they're swirling right now in the subterranean oceans of distant icy moons. We're quickly figuring out that the universe is basically this giant active chemistry lab. And the experiment? Well, it's already running. Here is our cosmic flight map for today's explainer. 1. The cosmic recipe for life. 2. Asteroid Bennu's prebiotic secrets. 3. Titan, a bizarre alternative. 4. Jupiter's hidden ocean worlds. And finally, 5. The Vanguard missions. Let's get right into it. Section 1. The cosmic recipe for life. So when we talk about this search, scientists aren't actually looking for little green men. What they're really looking for is prebiotic chemistry. These are the non-living chemical precursors, stuff like amino acids and nucleobases, that essentially snap together like molecular Lego blocks to activate biology. We are hunting for that exact critical moment where geology literally turns into biology. Moving on to Section 2, Asteroid Bennu's prebiotic secrets. Asteroid Bennu is this ancient space rock that just gave us the largest extraterrestrial sample ever brought back to Earth, all thanks to the OSIRIS-REx mission. And man, what they found inside completely blew researchers away. Think about how wild this is. This pristine 121.6-gram sample proves that the chemical precursors for biology were actually synthesized out in space long before Earth was even a planet. We found 14 of the 20 amino acids that Earth life uses to build proteins, plus all 5 of the canonical nucleobases you need to construct DNA and RNA. Add in some incredibly high abundances of ammonia and formaldehyde, and you can see that the raw materials to build even more complex molecules were just sitting right there in the extraterrestrial dust. But you have to wonder, how did they even get there? Bennu's unique molecular makeup tells us its parent body likely formed in a super cold molecular cloud way out at the very edges of the early solar system. We're talking about incredibly harsh environments where temperatures plummeted down to minus 400 degrees Fahrenheit. That deep freeze is what allowed volatile gases to just freeze solid and accumulate inside the rock. But here's the twist. It didn't stay freezing forever. Deep inside the sample, scientists found a completely intact set of evaporites. Finding these minerals is a huge deal because it tells us that the interior of Bennu's ancient ancestor actually contained a warm, liquid, alkaline saltwater broth for thousands of years. It was this insulated underground ocean that facilitated the complex organic reactions necessary to generate those very building blocks of life we just talked about. Which brings us to Section 3, Titan, a bizarre alternative. So while Bennu shows us the building blocks for life as we know it, Saturn's massive moon, Titan, forces us to ask a totally different question. What if life doesn't actually need water at all? See, we have this massive bias for water-based life because, well, that's all we know here on Earth. But Titan has rain, rivers, and entire lakes made out of liquid methane and ethane, all operating at a staggering 290 degrees below zero. Now, Earth cells would instantly freeze and shatter in that, but these liquid hydrocarbons could theoretically serve as solvents for a completely strange, freezing biochemistry that is entirely alien to us. And Titan actually has the chemical inventory to pull this off. Up in Titan's atmosphere, sunlight breaks apart methane and nitrogen, which then recombined into molecules like vinyl cyanide. Based on our data, there could be as much as 10 billion tons of this stuff sitting in just one of Titan's lakes. The sheer massive scale of chemistry is crucial because vinyl cyanide might actually be able to form flexible cell membranes that can survive and function in those extreme deep freeze conditions. All right, Section 4, Jupiter's hidden ocean worlds. Remember Enceladus and those massive geysers shooting out into space we talked about at the very beginning of the explainer? Well, that kind of active subsurface water is exactly what points us toward the absolute holy grail of this search, Jupiter's icy moons. Despite being locked inside ice sheets that can literally be over 100 kilometers thick, moons like Europa, Callisto, and Ganymede are hiding vast subterranean oceans. Jupiter's intense gravity is constantly stretching and squeezing their rocky cores, and that generates enough internal heat and tidal friction to keep those oceans completely liquid, even in the pitch dark. These icy moons are definitely not just sterile, silent rocks. They are active, dynamic worlds. Their crusts are constantly creaking and groaning as these gigantic fields of ice grind together. And, very much like those geysers on Enceladus, if there is biological activity swirling around hydrothermal vents at the bottom of these oceans, the plumes from cryovolcanoes shooting up through the ice could carry molecular signs of life straight out into the vacuum of space, basically just waiting for us to fly by and catch them. And that leads us to Section 5, the Vanguard missions. To actually pierce these icy shells and test these theories without having to land, humanity has engineered some truly incredible Vanguard missions, starting with NASA's Europa Clipper. The Clipper has a really long 6-year journey ahead of it. To build up enough speed, it's using some incredibly complex planetary gravity assists, whipping around Mars and Earth just to finally arrive at the Jupiter system in 2030. It's a genuinely mind-blowing feat of orbital mechanics. Now, because Europa sits incredibly deep within Jupiter's harsh, spacecraft-destroying radiation fields, the Clipper can't just park itself in a nice, steady orbit around the Moon. A probe would get absolutely fried in a matter of months. So instead, the Clipper is using this really clever step-by-step strategy. It's going to enter a wide orbit around Jupiter and then dive in for 49 close, rapid flybys of Europa. This minimizes its radiation exposure while it furiously gathers and transmits data back home. During those flybys, a suite of instruments is going to work together to completely map out Europa's hidden ocean. Reason will bounce a radar straight through the ice to check its thickness, while PIMS measures the magnetic fields to figure out the ocean's depth and salinity. But the SUDA instrument, that is the real game changer here. This mass spectrometer is going to literally fly right through those ejected ice plumes. It is so ridiculously sensitive that it can detect the chemical signs of cellular material inside a single microscopic grain of ejected ice. Seriously, if there is life spraying out of Europa, SUDA is built to sniff it out. Working right alongside the Clipper will be the European Space Agency's JUICE mission, which acts almost like a coordinated planetary tag team by humanity to uncover these secrets. While Clipper is hyper-focused on Europa, JUICE is out there characterizing Ganymede, which is actually the only moon in our solar system with its own magnetic field. By studying Ganymede and Callisto together, JUICE is going to give us a solid comparative baseline for ocean worlds and gas giant systems across the entire universe. So from the pristine, life-building dust of asteroid Bennu to the bizarre methane lakes of Titan, those dramatic geysers of Enceladus, and the vast, dark subterranean oceans of Jupiter, our entire understanding of habitability is constantly expanding. We're quickly learning that the universe is far, far more creative than we ever gave it credit for. As these incredible spacecraft finally begin to unlock the secrets of these ocean worlds over the next decade, we're really standing on the precipice of a new era in science. If the chemical broth of life is bubbling under miles of ice right now, or frozen inside ancient asteroids, what other astonishing alien wonders are just over the horizon? Keep your eyes on the outer solar system, because the answer, well, it might just change absolutely everything.